Hello everyone. So today we'll be solving some reverse engineering challenges from PicoCTF. So let's start with Bit-O-Asm-1. So the description says, can you figure out what is in the EAX register? Put your answer in the PicoCTF flag format wherein is the contents of the EAX register in the decimal number base. If the answer was 0x11, your flag would be PicoCTF 17. So basically, we need to just get the contents of the EX register and we need to enter it in decimal format. Okay. So you can download the challenge file from here. I've already downloaded it and I'll directly move to the challenge. So as you can see, we have a very basic assembly code and we just need to get what is in the EX register. So if we read these starting instructions, these are just setting up the stack frame. This is the address where our arguments will be stored. But as of now, it is not useful. So we just need the value what is in the EX register. If you look at this instruction plus 15, it is moving 30 into EAX register, right? 30 is in hexadecimal. So we just need to convert it to decimal. We can do that using Python. So yeah, so it is 48 in decimal and let's enter it in here as 48. Okay, so yeah, it was just it, like it is moving 30 into EX register. The right argument is moved into the left one. Okay, and if you look at the starting instruction, these are just setting up the stack frame, like it is taking our first argument and here it is the address of base pointer minus 04. And here again it is the address and it is taking the second argument, but here it is not useful, but you should know what it means. Okay, and if you look at it, here it is dword and here it is keyword. Dword actually means double word and keyword actually means quad word. So the size of a word is 2 bytes. So dword actually means 4 bytes and keyword actually means the size will be 8 bytes. So that is 64 bits. Okay, so let's move to the next challenge. So what we have here, again the description is same and you can download the challenge file from here and we just need the contents of the EX register. Okay, so again it is a simple assembly code. It is similar to the previous one. The initial instructions are just same. It is setting up the stack frame. Okay, so we need to focus it from here. It is moving this value into this address, that is base pointer minus 0 cross 4. Okay, so what is this value? Let's see. So it is 65,004, sorry, 6,54,874. Okay, so now it is moving this value at this address into EX register, and at this address we have this value. Okay, so in the EX register it will be this value in decimal. So now we can submit the flag. We need to copy the decimal value. Okay, so it was pretty easy. Let's move to the third one. Okay, so again it is a basic assembly code, and again we need to get the content of the EX register. So if we look at this instructions from this plus 15, again it is moving this value into this address. So yeah, this value is 654874, and now it is moving 04 into this address. Okay, and that is 4. So now it is moving the value at this address, and at this address we had this one. Okay, so it is moving now. It is moving that in EAX. So in EAX we have now. In EAX we have this one. Yeah, we can write this. Yeah. So now it is multiplying this value in the EAX with that value in this address RBP, that is base pointer register minus 0 cross 8. So what was the value in this register? It was 4. So we will multiply this value with 4. So we can write EX. Okay, so now what we have in EX, it is this value. Let's see. Now it is adding the value in EX with this value. And we can do that. Let's see what we have in EX now. So yeah, here is the decimal value. Now it is again moving the value of EX into base pointer minus 0 cross 4 register into this address basically. The thing in this square bracket is the address. Okay. So it is moving the value into this address. So now it is again moving that value into EX. So the final value in EX register will be this one. Let's see if we are correct. Okay, we are. So let's move to the last part of this challenge suit. Okay, we have some new instructions over here. Again, as you can see, it's moving this one into this address, this one into this address, and it is comparing here. Here it is comparing. So it is actually comparing this value with this value. And JLE, this instruction refers to jump if less than or equal to 0. So what it is checking? It is checking if this value is less than this value, less than or equals to. But it is not, right? If you see the decimal part, although it is pretty much observatory, but if you even check the decimal part, you can see that this value is greater than that. Okay, so it means that it is not gonna jump. It was actually jumping to main plus 37, so it would have jumped here if it would have been greater than this, but it is not, so it will not jump, so it will move to this instruction, that is subtraction. Okay, so what it is doing, it is basically subtracting the value at this address minus 65, like subtracting cross 65 from the value at this address. So what we have at this address, it is basically this value, right? Okay, so we can just copy this and let's see and subtract it with 0 cross 65, and we have this value now. Now it is jumping to main plus 41. So this is the instruction, and it is moving this value into EX. So the final value in EX will be this one. Okay, so let's see. Yeah, PicoCTF. Yeah, we got the challenge. So these were some easy assembly language challenges. You just need to have a good grasp of assembly instructions, and if you are learning reverse engineering, then you should be able to understand basic assembly language code. Otherwise, you will face a problem when reversing much more larger challenges. Okay. So we'll meet in the next video again with some new challenges.